Assalamu alaikum student, mathematics 4024. Welcome to Maths Guru. Student, this is again a question from coordinate geometry. The exercise is 6b, the book is D3. This time we are solving question number 9. The question is already solved, so we just have to look at the solution. The question has two parts. In the first part, we have to show that the points A, B and C are forming a triangle and the triangle is an isosceles triangle. And in the second part, we have to find the area of this triangle, that is ABC. So before moving to the solution, we are starting with the plotting of the triangle first, since we have to find the area of the triangle. So it's better to draw the triangle since the coordinates are given. So we are now first drawing the triangle, and we will use these three coordinates. The first one is A, minus 1, 2. The second one is B, 5, 2. And the third one is C, 2 and 5. You know, the first value belongs to X and the second value belongs to Y. So this is my Cartesian plane, this is my y-axis, this is my x-axis, this is the positive side of x, this is the negative side of x, this is the positive side of y, and this is the negative side of y. So since my first point is minus 1 and 2, the value of x is negative 1 and the value of y is positive 2. So I will just move on the negative side one block, and then I have to go up to 1, 2. So this is the location of point A, minus 1 and 2. Now I have to mark my B. B is 5, 2. Both are positive. So the value of x is 5 and the value of y is 2. So this is 5 and this is 2. This is the location of point B. And C is 2 and 5. So 2 on the positive side of x and 5 up. 1, 2, 3, 4, 5. So this is C. So by joining these three coordinates, this is my triangle ABC. And now I have to prove that this triangle is an isosceles triangle. What is an isosceles triangle? A triangle that has two equal sides is known as an isosceles triangle. So what I have to do over here is that I have to find the length of all the three sides, and I have to see whether the length of two sides are coming equal. If the two sides are coming equal, then I have shown that this triangle is an isosceles triangle. Since the question is asking you to show that, so you have to do the working. You cannot write the answer directly. You have to show by your working that this triangle is an isosceles triangle. So we will just start off with finding out the length of all the three sides. We are starting with the length of AB first. Why? Because AB is a horizontal line, or you can say a straight line. So we do not need to use the distance formula now. We will just count the number of boxes. So since this is a straight line, so I will just count the number of boxes to find out the length of AB. 1, 2, 3, 4, 5, and 6. So 6 units is the length of AB. And now in order to find AC and BC, I have to use a distance formula since the line is slant. I cannot count out the number of boxes. So I am starting with the length of AC first, since A is my first coordinate. And what are the coordinates? Minus 1 and 2. This is the value of x1 and this is the value of y1. C is 2 and 5. This is the value of x2 and this is the value of y2. So now you all know the distance formula now. Square root x2 minus x1 whole square. What is the value of x2? x2 is 2. So this is 2 minus. And what is the value of x1? x1 is negative 1. So I have used a bracket like this. Minus 1 bracket close whole square. Then comes the positive sign. Then comes y2 minus y1. y2 value is 5 and y1 is 2. So 5 minus 2 whole square. This negative and this negative. Minus multiplied by minus will give me positive. 2 plus 1 will give me 3, and you know that 3 square is 9. And again the positive sign, and 5 minus 2 is again 3, so 3 square is again 9. So square root of 9 plus 9 will give me square root of 18. If you want to write it in decimal, you can also write it in decimal, but I am leaving my answer over here since I do not need this answer in my further calculation. So I'm just leaving my answer over here. So this is square root 18 units, and the first length is 6 units and the second length is square root of 18 units. So now I have to find out the third length, and I have to show that the third length is also coming out as the same as one of them. So I'm starting with BC. B is my first coordinate. The coordinates of B is 5 and 2. The value of x1 is 5, the value of y1 is 2, and C is 2, 5. So this is the value of x2, and this is the value of y2. It doesn't matter. You can label it as x1 and y1, and this one as x2 and y2. It doesn't matter. Your answer will be the same. But since I have used the same method or in the whole chapter, that I use the first point. This is BC, so B is my first point and C is my second point. So I will just label B as x1 and y1 and C as x2 and y2. But if you want to change the sequence, it doesn't matter, the answer will be the same. So now using the distance formula, square root x2 minus x1 whole square, x2 is 2 and x1 is 5. So 2 minus 5 whole square plus y2 minus y1, what is the value of y2? 5 minus 2 whole square. 2 minus 5 is negative 3, and square of a negative number means minus 3 multiplied by minus 3 will give you positive 9, and plus sign as it is. 5 minus 2 again is 3, 3 square is 9. So 9 plus 9 is again 18. So this is also coming out the same as AC, that is square root of 18 units. So since two sides are, the length of two sides are equal, so I have proved that this triangle is an isosceles triangle. You just have to write one line. Since the length of AC and the length of BC is coming out as equal, that is square root of 18 units. So this triangle is an isosceles triangle. Now moving to the second part, in which we have to find the area of the triangle. We know that in order to find the area of a triangle, we have to use the formula half into base into height, and now we have to identify which one is the base. So since this is the flat side, this is the horizontal line, or you can say this is the straight line, so we are taking this as the base. So AB is our base, and what will be the height? A perpendicular line from top to bottom will be our height. So this is the height of the triangle, which I have written as h, and this is the base of the triangle. Since these two are horizontal and a vertical, so we will just count the number of boxes. The base is 1 2 3 4, 5, and 6. So the length of base is coming out as 6. And what about the height? The height is 1, 2, and 3. 3 boxes. Since one box is equal to 1 unit, so this is 3 units. The height is coming out as 3 units. And the base is coming out as 6 units. So half multiplied by 6 multiplied by 3. 2 times 1 is 2, and 2 times 3 is 6. So 3 multiplied by 3 is equals to 9. The area of triangle ABC is coming out as 9 unit square. Since we don't have any unit here, so we will just use the units. So this is question number 9, in which we have to show two triangles as an isosceles triangle. If the length of all the three sides are equal, that is called an equilateral triangle. An isosceles triangle is a triangle in which only two sides are equal. Only the length of two sides are equal. So this was question number 9. I hope you have understood this question. This was a very simple question. You just have to apply the distance formula, and it's better to draw a figure in coordinate geometry, because whenever you have to find the area, just remember the hint that you have to draw the figure first. The figure will tell you what is the base and what is the height, so it will be easier for you to find out the area of the triangle.